Alright y'all, this is the Stoichiometry video tutorial. Today we are looking at pages 5 and 6 in your homework packets. So, as always with our class, you have to show your work. No work, no credit. And work starts by boxing in your given, your number, unit, and compound, and circling the unknown unit and compound. Okay? Odds are your teacher worked these first couple with you in class, gave you time. So I want to jump down here at the bottom of this page. And again, the questions come in groups. So it says use this equation for problems 4 through 6. We've got aluminum carbonates plus 6 sodium yields 2 aluminum plus 3 sodium carbonates. As a single replacement reaction. Okay, this first one is asking me for a mole ratio, and it's not really giving me a ton of information. So it's asking for sodium and sodium carbonate. So I've got 4 options. 1, 2, 3, 4. 4 different chemicals in this reaction. One of them is sodium. Ding, ding, ding. That one, just Na. So the mole for sodium is 6. For sodium carbonate, that's aluminum with carbonate. That's just sodium. That's nothing. Sodium and carbonate. So without having to write the 4-step formula, I can figure out that this is sodium carbonate. So its mole ratio would be 3. So 6 moles of sodium equals 3 moles of sodium carbonate. That's what we use the mole ratio for. Alright, let's start. Let's dig in. Okay, so if 35.2 grams of sodium, there's my given number, unit, and compound. Alright, so I'm going to box this whole thing in as my given. Were to react, how many grams of aluminum could be collected? That's what they're asking me to find. It's grams of aluminum. So I boxed my given, I've circled my unknown. Alright, now I'm going to start my work all the way over here to the left, because this could be 1 or 2 or 3 steps. So I'm going to start it all the way over here, just in case. And whatever I boxed in is going here. 35.2 grams, and I'm going to use the formula, not the name. It's Na, grams of sodium. Okay? For sure, we're going to disco our unit. The top unit comes down like a disco. So grams, Na, is coming down here. And I'm going to do this next part in pencil because it is not allowed. I want it to be grams of aluminum. I can't do that. Okay? So we learned back on page 1 that I'm only allowed to change compounds from aluminum to sodium if I have mole on top and mole on bottom. I've got grams on bottom. So for sure, until I have moles on bottom, I'm not allowed to change compounds, which means my answer has to stay sodium. I have to stay in the same compound on top and bottom. So what I can do is turn it into moles so I can get closer. So I can put moles of sodium on top. So from grams of sodium to moles of sodium, but I wouldn't be done. Now I'm going to just go down mole of sodium. Okay? Because I have moles on bottom now, I am green to go. That's the terminology we learned in my class. I'm green to go, which means I can change compounds. So if I have moles on bottom, I can put moles on top, and then I can turn it into aluminum. Okay? That's still not what I want. I want my answer to be grams of aluminum, but at least I got myself to aluminum, which means we need a third step. I'm going to bring down moles of aluminum. And since I already have aluminum on bottom, I can turn it into grams of aluminum on top. Okay? So before I can start changing compounds, just like we did last time, I have to get to moles first. So from grams of sodium to moles of sodium. Then I can change compounds with moles. Then I can turn into grams of the thing that I want. So this is a 3-step problem. A mole always gets a 1 in front of it. So mole over grams, I'm going to put a 1 here. This one's mole over mole, that's different, but mole under grams, that's getting a 1. Mole always gets a 1 in front of it. Grams always gets a molar mass in front of it. So I need to find the molar mass of sodium for this one, which is here, 22.990. Okay? A mole always gets a 1 in front of it unless it's mole over mole. Then I use the coefficients in my balanced equation. So for aluminum, the coefficient is 2. For mole sodium, I need the coefficient of sodium, which is here, 6. Okay? Then 1 mole equals the molar mass of aluminum. And for aluminum, we're right here, 26.982. Now, I very deliberately put all of my units out. I did all 3 steps before I started talking about numbers. Okay, units are your best friend. They will organize the problem for you. Once you have the units correct, then we can go back and worry about numbers. That's the most common mistake I see from students is them trying to take a shortcut, which this is the shortcut, or trying to go kind of out of order. Okay, so all 4 of my numbers on top get multiplied. 35.2 times 1 times 2 times 26.982. And you know what? I typed that in wrong, but I can fix it. 26.982. So my top number, that's not my final answer. Now I need to divide by each of the bottoms. So divided by 22.990, divided by 6, divided by 1, 13.69. So I'm going to write that, 13.69. And for my units, I'm going to see what I have left if I cross out the stuff that I've already used. So if it's on top and bottom, it goes away. Grams of sodium is eliminated because it's on both sides. Mole of sodium is eliminated. Mole of aluminum is eliminated. And that only leaves me with grams of aluminum as my unit. Okay? It's a big process. For number 6. Number 6, we're starting and ending in a different spot. So you'll notice it says 22.5 grams of aluminum carbonate. Make sure you don't forget that carbonate spot. That whole thing reacts. How many moles of aluminum will be produced? So for number 5, I was going from grams of one thing to grams of another. This one I'm going from grams of one thing to moles of another. So it's not going to be the same number of steps. Okay, because I'm going to a different distance. I'm still going to start all the way over here so I don't have issues. I'm going to put 22.5 grams aluminum carbonate. I'm going to come up here, just like I did on number 4, and figure out one of these 4 things is aluminum carbonate. Heyo, that's aluminum stuck to something else. So that's my formula I want to use. Al2CO3, 3. And that's going to happen. Okay. I disco down my units. Grams, Al2, CO3, 3. And what I want to do, I'm going to do in pencil, is to turn it into moles of aluminum. No way. Can't do it. I can't turn one compound into another compound unless I have moles on the bottom like I did here. So on number 5, this is where I changed compounds because I had mole over mole. I don't even have mole on the bottom. So I can turn it into moles, but it has to say that same compound. It has to say aluminum carbonate. I'm not allowed to leave. Al2CO3, 3. So I kept the same compound, but I could change it to moles, which means I need another step. I'm going to bring this unit down. Mole, Al2CO3, 3. Do I really have to write it over? Yeah, just write it. Otherwise you're going to get lost sometimes. Okay, you give room for mistakes. I have mole on bottom, which means I am green to go. I can change compounds. So now I can go to the compound I want, which is aluminum, as long as I have moles on top. And heyo, that's where my problem asks me to stop. It doesn't ask me to take another step to grams. It tells me I can stop at moles. So this is only a 2-step problem, and that is just fine with me. So now that I've done all of my units, I'm going to come back and look at numbers. A mole always gets a 1 in front of it, so right here, unless it's mole over mole. Then I need the coefficients. So on top, mole aluminum, I need the coefficient for aluminum, which is 2. On bottom, mole aluminum carbonate, I need coefficient for aluminum carbonate, which is nothing, which just means invisible 1. So I put the 1 there. Okay. For grams, grams gets molar mass, which is yucky. I don't want to do that, but we gotta. Okay, grams of Al2CO3, 3. So that means, I'm going to do my work over here. That means I have 2 aluminums. I have 3 times 1 carbon, so I have 3 carbons, and 3 times 3, so I have 9 oxygen. Okay. So I'm going to add all those up. Yay, it's so fun. Okay, 2 aluminums, Watch me do my math wrong now. 2 aluminum, so 2 times 26.982 for aluminum equals, so that answer plus 3 carbons, so parentheses, 3 times carbon, close my parentheses, okay, plus 9 oxygen, so that answer plus 9 times 15.999, close my parentheses. That's the molar mass of aluminum carbonates. Thank you for being annoying, aluminum carbonates. So I'm going to put that here. 233.988. Okay, I did all my units. My units help me pick my numbers. Now we can plug her in. So top numbers, we multiply by each. 22.5 times 1 times 2 divided by 233.988 divided by 0.19. Okay, 0.19. You can put 23. Technically, if we rounded it for significant figures, that would be my answer, 0.192. Well, I'm not that bothered by significant figures, though. So for units, these guys are top and bottom, so they cancel out. Moles of aluminum carbonate cancels, and that leaves me with moles of aluminum. Okay. Yeah, there's a lot to this. Okay, this doesn't go away. This is what we're doing for the next couple of days in class, so please make sure we're getting help if we need help. I'm going to do a couple more problems like this. Let's look at number 7. Okay, number 7, we're using this combustion reaction. So we've got butane, oxygen, carbon dioxide, water. It's a combustion reaction. And number 7 is just asking me for mole ratio. So for oxygen, it's coefficients. The coefficient of oxygen is 13. And for carbon dioxide, the coefficient is 8. I want to look at, I put 9 and 10, but I actually want to do 9 and 11 with y'all. Okay. Boxing in your given. So where I am and where I'm going. Grams of carbon dioxide, that's where we're starting our map. And we want to end in grams of oxygen. It is not a bad idea to memorize that whenever you have gram of one thing and you're going to gram of a second thing, that is going to be a 3-step problem. Okay. I would encourage you to memorize that. I have grams to grams. Great. That's the big, long problem. So I'm going to go ahead and set up my work like that. That way I know what I'm looking for. Right, so 100.0 grams of carbon dioxide, and I'd look up here and say, of my choices, that one is carbon dioxide, so CO2. I just go down, grams of CO2, and I can't leave. If I have grams on bottom, I have to stay as carbon dioxide. So I have to keep carbon dioxide on top, but I can turn it into moles at least. Okay, that gets me one step closer. Take moles and bring that down. Moles of CO2. And as soon as I have moles on bottom, I'm green to go. I'm allowed to change compounds now. So I have moles on bottom, which means I want to change compounds from carbon dioxide to oxygen. Be careful, careful, careful. Oxygen up here is not O. It is O2, and that makes a huge difference when we do our math in just a second. So I'm going to change compounds, which I'm allowed to do because I have mole over mole. Excuse that bell. So because I have moles on bottom, I can change compound. This question doesn't want me to stop, though. It doesn't ask me to stop at moles of oxygen. It wants me to stop at grams. So then we do our third step. I bring down mole of O2. And now that I'm in O2, I can finally get to grams of O2. I did all of my units because they are so nice. They tell me what numbers to use. So I know that a mole gets a 1 in front of it. Here and here. Unless it's mole over mole, I don't put 1s there. When it's mole over mole, I use the molar ratio, aka the coefficients. So for O2, check that out for a coefficient. That would not be fun to balance. 13 is my coefficient for O2. For mole CO2, my coefficient is 8. Okay. Grams gets molar mass. Molar mass of CO2. So that's going to be carbon, 12.011 plus 2 oxygens. So 2 times 15.999, 44.009. Okay, so 1 mole of carbon dioxide equals the molar mass of carbon dioxide. My balanced equation says 13 moles of this equals, on bottom, 8 moles of that. Right here, 1 mole of O2 equals the molar mass of O2. Okay, so if you put 15.999 there, you're going to get the question wrong. It's O2. It's one of those diatomics, which you should memorize. You don't have to memorize as long as you check the problem for it. So I know that it's going to be 2 times oxygen's molar mass, 31.998. Like this. Okay, that's why it matters writing the formula all of these times. Okay, let's plug this one in. 100.0 times 1 times 13 times 31.998. So I multiply by each number on top and divide by each on the bottom. So divided by 44.009, divided by 8, divided by 1. I divide by each and get 118.15. Technically for sig figs, if that bothers you, it should be 118.2. I really don't care. I'm going to say 118.15. Okay. And then for units, they all cancel out except for grams O2. That's a doozy. Okay, number 11 is a lot nicer. It's a lot nicer. 18.2 moles of water is collected. How many moles of oxygen was consumed in the reaction? So I'm starting in a very different place here. This one had me go from grams to grams. This one's starting me at moles, and it's telling me I can end at moles. Just in case, I'm going to leave a lot of room and put in my given. 18.2 moles of water, which is H2O. I just go down moles of H2O. And look, I'm already green to go. As soon as I have moles on bottom, I can change compounds. So I can go straight to oxygen now, which is O2, moles of oxygen. So here, when I started in grams, I had to turn into moles to get to this step. But basically, I'm starting here on this problem, which I love. And then look, I'm also done, because they asked me to stop at moles of oxygen. So, hallelujah, this is a one-step problem, just like pages 1 and 2 in this homework packet. Okay. So a mole always gets a 1 in front of it, unless it's mole over mole. Then I'm going to grab these coefficients. So the coefficient for O2 is 13. Coefficient for water is 10. So I'm going to let you finish calculating this on your own with units and multiplying and dividing. All right. Number 12, 13, 14, these are example test questions. So we added it on to the assignment as review. Stoichiometry is based on the law of conservation of mass, just like balanced equations are. Okay? So balanced equation says I'm not creating or destroying anything. Stoichiometry works because we have a balanced equation. If that's rusty, maybe make a flashcard, memorize that. Number 13 is using the law of conservation of mass. So it says if I have my propane reacting with oxygen in a combustion reaction to make carbon dioxide and water, my arrow, my yields, my reacts is the same thing as the equal sign. So X number of grams plus 80 equals 66 plus 36. We did this back in units 4 and 5, I think, last semester. Anyways, we did it first semester. So I need to combine like terms. I have blank plus 80, so there's nothing to combine. Over here I have 66 plus 36. I can add those and get 102. And then I want to get this by itself, so I'm going to subtract 80 from both sides and say minus 80 equals 22 grams. So 22 plus 80 is the same thing, is equal to 66 plus 36. Both sides add up to 102. Okay. Your teacher can start talking to you about this foldable or the mole math, the mole troll. So if you're really, really still struggling on this, come in for tutorials and ask for help with the foldable. Okay, and I will teach you how to use this on the next video as well. Thanks, y'all.